Hello everyone. I'm wondering whether you're hearing me.
Merhaba hocam.
Sesi geliyor mu?
Evet hocam
Hocam
geliyor.
biraz hızırtılı geliyor sesiniz ama
Başkası da mı böyle duyuyor?
Yani biraz hocam çok da rahatsız etmiyor aslında.
Şimdi kulaklıkla konuşsam böyle.
şimdi sanki daha iyi oldu hocam ya.
Evet öyle yapalım o zaman. Kulaklıkla yapalım işi. Ekranı paylaşayım. Biz WhatsApp grubu kurduk mu çocuklar sizinle?
Hayır
Hocam
hocam
E,
sanırım.
kurabilir misiniz? Yani bazen buradan sorun olur. Moodle'dan falan iletişim kurması açısından. Olabilir mi? Biriniz kursa.
olur hocam kurarız.
Tamam, beni de eklersiniz. Ben de sizinle telefonumu paylaşayım. Okay, this is my phone number for who will establish the WhatsApp group for this course. This is 0542 377 7290. Okay. Have you taken it?
Tamam ben kurarım isterseniz.
Okay, that will be very nice of you. Thank you. So I'm erasing this. Did you get it? Did you copy the number? I'm going to
Evet
erase it.
hocam. Hı hı.
Okay. Okay, we may begin the lecture today. In the previous 2 weeks, we have learned the hypothesis testing for population mean and the confidence interval for population mean. The way we constructed the hypothesis will be similar for the population proportion too in this lecture today. So let me show you what we do for the population proportion. Before I get to the hypothesis testing, let me define you the population, the symbol population. We use basically the universal representation of the proportion. Population proportion is pi. That's the symbol we're using. Although in the book they use a capital letter of P, I prefer the pi. This is much more universal. So this is the population proportion. Population proportion. We assume that this is not easy to determine the population proportion. We use a sample proportion to estimate the population proportion. So the hypothesis testing we use for the population proportion are three ways, three different hypotheses we can construct for the population proportion. There are three different hypothesis testing for population proportion. So Those are the hypotheses we construct. We have also two hypotheses, one the null and the other one is the alternative where the claim is included. So the null hypothesis, the first one we construct the null hypothesis, pi is greater equal pi null, and the alternative is going to be pi is less than pi null. So this is left-sided or left-tailed. You may treat it as left-sided or left-tailed. Left-sided or left-tailed. The other one, which is the right-sided or right-tailed, would be in different direction, the null hypothesis. Pi is less equal to the pi null, and the alternative, pi is greater than pi null. And this is right-sided or right-tailed. Okay, the final one, last one, the null hypothesis. Now this time you establish it as equality. Pi equals pi null, and the alternative pi is not equal to pi null, and we call it double-sided, two-sided, or two-tailed. So to test such hypothesis with alpha, you will have to use alpha level of significance, of course, to test such hypothesis. We use an alpha level of significance and so this Z and the test statistics test statistics that is used is given as follows. So this is the calculated statistic. We use also the standard normal approximation statistics, Z-calc, which is the calculated statistics, pi hat minus pi null, and divided by within the square root pi null times 1 minus pi null, and this is divided by the sample size. Okay, that's the calculated statistics. The way we test such hypothesis will be the same as the procedure we have followed in the previous 2 weeks. The calculated statistic is compared the critical value as we do before. Okay. And there are some critical values Let me use some critical values. Those are some critical values we mostly encounter. Okay, let me show you. So if the alpha level of significance and z1 minus alpha, so if it's 0.10 and this is 1.28, or you can bring this value from the standard normal distribution table. 0.05, this is 1.645. I have given all these critical values 2 weeks ago. And 0.01, another one, which is, no, not this one. I'll have this one first. 0.25, this is 1.96, and 0.01, this is 2.33, and we have one more, 0.00 and 5, this is 2.5, 7, and 5. Okay, if you know all these critical values, and you won't need to use a standard normal distribution table anymore. Let me just box it. Okay. All right. Let's have an example. I'll write the example down. Or maybe I can use this space here. Example. Okay. Students of Athlone University prefer using iPhone more than 20% by using iPhone, more than 20%. This statement was on Billboard and in the previous semester, billboards of Athlone University in the previous semester. To test whether that claim is true or not, um, 250 students 50 students are randomly selected. And I need to pick up this phone call. I'm so sorry. Alo. Nereden arıyorsunuz? Ha, iyiyim, teşekkür ederim. Siz? Yatırmıştık biz. Bir daha kontrol edin. Evet. Birkaç saat önce yatırmıştık. Yani geçmiş olması lazım. Epey oldu. Dekont da geldi bana yatırıldığına dair. İsterseniz bana bir mesaj atabilirseniz WhatsApp'tan size bir dekontu göndereyim. Tamam, tamam. Teşekkürler. İyi günler. Okay, so sorry for the interruption. 250 students are randomly selected and and fifty of those are determined to use a model of iPhone. One of the models of iPhone use one of iPhone is there evidence to say that the students of Athlone University are using iPhone with more than 20%. Establish a 95% confidence interval for proportion of iPhone usage at Atılım University. Okay, I realize that I haven't given you the alpha level of significance in this example, but you may consider its alpha is 0.05. So if you can't see any alpha level within the exercise, within an example, just consider the universal one, which is 0.05 level of significance. So let me start the solution. Okay. So if you read back the example, you will understand that the null hypothesis would be null. The pi would be less equal 0.20, and the alternative would be the pi is greater than 0.20%. So we're telling that 20% of the students, more than 20% of the students are using a model of iPhone at Atılım University, the students of Atılım University. So we think that the alpha level 0.05 level of significance, and we need to have the critical value, which is that 0.95, that is 1.645. Another thing is we need to determine the pi null is already given 0.20, and we also need to determine the sample proportion. So you have picked 250 students, and you ask whether they are using one of the models of iPhone, and you found out 50 of them are using an iPhone model. And this is 50 divided by 250, and this is exactly 0.20, but I will change it. I'll change it to 60. I'd like to change it to 60. I'll change this to 60. So yeah, this is 60. Yep. There you go. 60. This is 0.24. It becomes the pi null is 0.24. Okay, what else we need to write? We need to calculate the statistics. The Z calculated statistics. Remember, it was pi hat minus pi null, and this is divided by pi null times 1 minus pi null, 1 minus pi null, and this is divided by the sample size. And there you go. So let's substitute whatever we need here to get the calculation done for the calculated statistics. The pi null is already calculated as 0.24 minus, and pi null is 0.20, and we have 0.20 times 1 minus 0.20, and this is divided by 250. Okay, this statistics would be if we perform the calculation. Let's see what we have. 0.24 minus 0.2 divided by square root 0.8 divided by 250. The result is 1.58 and 11. Okay, and if you look at the sample proportion, which is 0.24, and you can tell that you may reject the null hypothesis and support the alternative and tell that the proportion of using an iPhone would be larger than 0.2 or 20%. So it's since the sample proportion is 24%, you may think in this way, but this is not true. Or statistically, we may not be sure for this. You have to check whether this is absolutely statistically significant. So we perform the calculated statistic, and the calculated statistics is 1.5811, and we know the critical value, which is 1.645, and this is a right-sided hypothesis. We have to construct the critical value, the critical region on the right side of the Gaussian distribution. Let me just have your graphical display of the Gaussian distribution. Look. Okay, for this example, I will have the critical value on the right side. So I have the critical region right here. Okay, this is a rejection part, reject region. The null 0.05. Do not reject the null. This is 0.95. In our example, this is 0.95. Okay, the critical value, we know it is the critical value is 1.645. So I can just place it in the position of the critical value. This is 1.645. And the calculated statistics is simply falling within the accept region. So this is okay, the calculated statistics, which is 1.5811. Okay, since 1.5811 is not falling, is falling within the area that is not supporting the rejection of the null, then the null hypothesis is not rejected with alpha 0.05 level of significance. In other words, there is no evidence tell that the students of Athlone University. Using a model of iPhone, one of the models of iPhone. By more than 20%. With 0.05 level of significance. Okay. So let me show you the confidence interval. 100 times 1 minus alpha percent confidence interval for population proportion. Yep. Okay, let me show you how we establish the confidence interval. So we will have pi hat minus the critical value Z1 minus alpha divided by 2 times pi null times 1 minus pi null, and this is divided by the sample size, and this is within the square root. Let's equal pi hat plus Z1 minus alpha divided by 2 times pi null times 1 minus pi null, and divided by the sample size n. Okay, that's the confidence interval we write and construct the confidence construct and 95% confidence interval for population proportion for the previous example. Okay, we have everything to establish the confidence zone except for the critical value. So alpha, if the confidence 95% is the confidence level, then alpha is 0.05. As a result, that 1 minus alpha divided by 2 would be Z 0.975, which is 1.96. This is the critical value we need to use And let me just substitute whatever I need for the confidence interval. The pi hat was 0.24. We have calculated this as 0.24 minus 1.96 times pi null is 0.20. 0.20 times 1 minus 0.20 divided by 250. And this is within the square root. I may copy this and just